There is a specific kind of heartbreak that comes with visiting your childhood home.
Mm.
You know the feeling, right? You go back to the neighborhood you grew up in, maybe, I don't know, 5, 10 years later.
Boy.
You walk to the edge of the schoolyard and you're looking for the marigolds you used to pick, or that one gnarly tree where you scraped your knee and you just find concrete.
Oh, the nostalgia trap. It hits hard.
It does. It really does.
Hmm.
Instead of butterflies, you find scaffolding. You find a construction site.
Right.
And the soft grass is just gone. It's buried under some massive apartment complex. It's so disorienting.
It's a jarring image. You expect permanence, but you find a parking lot instead.
Exactly. And that is exactly where our source material starts today. It opens with this story of character, Ravi, who faces this exact realization.
Mm-hmm.
He's standing there, the text says he's almost in tears, just looking at his lost playground. And when he talks to his principal about it, the principal just sighs and says, "See how our environment is changing."
It's such a simple narrative,
Yeah.
but wow, it does a lot of heavy lifting.
It does, doesn't it?
It anchors a massive geographical concept, this idea of natural vegetation, in a very real, very human emotion.
Absolutely.
It reminds us that all this stuff we're about to study, you know, the forests, the grasslands, it isn't just green stuff on a map.
No.
It's fragile. It's the living skin of the planet.
And that is what we are unpacking today. Welcome back, everyone, to the Deep Dive. This is a special edition presented by the Simplified UPSC by PPP YouTube channel.
And we have a very specific mission today.
We do, a very clear one. We are tackling NCERT Class 7 Geography, Chapter 6, Natural Vegetation and Wildlife.
But, and this is the important part, we are not just going to read you a textbook.
No, that would be a complete waste of your time. We're going to deconstruct it.
We're going to take the core concepts from this chapter and we're going to cross-reference them directly with past year questions, PYQs, from the UPSC Civil Services exam.
We want to show you the difference between reading a chapter and, mastering a chapter.
That's the key distinction.
Because it's one thing to know what a tree is. It's a completely different thing to know how that specific tree earns you 2 marks in the preliminary exam when the pressure is really on.
Exactly. We're moving from just general knowledge to exam logic.
Now, before we start climbing mountains and trekking through these jungles, I do have a humble ask. If you find value in this deep dive, and I mean, if you want us to keep decoding these chapters and digging up these PYQs for you, please subscribe to the Simplified UPSC by PPP channel.
It really does help the algorithm find other serious learners just like you.
It does. And if you are capable and feeling generous, please consider supporting us on Patreon.
That's the fuel for this engine. It lets us do the deep research to make these, well, to make them actually useful rather than just fluff.
And a huge shout out to the patrons who are already with us. You guys are literally keeping the lights on. We appreciate it so much.
Thank you.
Also, quick resource alert. You don't need to be frantically scribbling down notes while you drive or work out. We've put free notes, including all the PYQs we discussed today, on the public Telegram channel.
And for the real power users out there, there's the private Telegram library.
Right.
That's where you get the premium stuff, the really detailed summaries, extra PYQs, and organized model mains answers. Just DM us on the public channel if you want to join that inner circle.
Okay. Housekeeping is done. Let's get into the geography. We started with Ravi and his lost playground, but the text, it shifts gears pretty quickly to another character, Salima.
Right, Salima. She's going on a summer camp to Manali in Himachal Pradesh. And this is where the geography really kicks in.
Okay.
As her bus climbs higher and higher into the Himalayas, she's looking out the window and she just notices the world changing around her.
She's watching the landscape literally morph in real time.
Precisely. In the foothills, she sees these deep, dense jungles of sal and teak.
Okay, broad leaves, very thick.
Exactly. But as the bus gains altitude, they disappear. Suddenly, she's seeing these tall trees with thin, pointed leaves and cone-shaped canopies.
The classic mountain trees.
Right. And by the time she gets to the Rotang Pass, it's just short grass and snow.
It's a vertical transition. It's like traveling from the equator to the pole, but you're just doing it by driving up a hill.
And that single observation is the foundation of this entire chapter. It gives us what I like to call the core equation of biogeography.
The core equation?
If you understand this equation, you can basically predict the type of vegetation anywhere on Earth.
Okay, I'm listening. What is it?
Height plus climate equals vegetation.
Height plus climate equals vegetation. Okay, let's break that down because climate is a pretty big word. What are the actual levers being pulled here?
The two heavyweights, the main drivers, are temperature and moisture.
Okay. Let's start with temperature. How does that work?
So think about Salima's bus ride again. As she goes up, the temperature drops. We all know this concept. It's the lapse rate.
Mm.
Generally, for every kilometer you go up into the troposphere, the temperature drops about 6.5 degrees Celsius.
So the engine of growth, the heat is basically slowing down.
It's being turned down, exactly. Photosynthesis is a chemical reaction. It likes warmth. As it gets colder, the metabolic rate of the plants slows way down.
Okay.
So a cell tree, which loves a certain warm temperature range, simply cannot function at 3,000 meters. It shuts down.
It hits a biological wall. Makes sense. And what about the other lever, moisture?
Moisture profiles also change with altitude. The capacity of the air to hold water changes. But more importantly, if you look across the globe, moisture is what determines the density of vegetation.
So a simple rule of thumb.
A very simple one. High moisture equals forest. Moderate moisture equals grassland. And low moisture equals desert.
It's a sliding scale.
It is. And the text also mentions two secondary factors, which are also important: slope and soil thickness.
Slope is interesting. Why does the angle of the mountain matter so much? I mean, dirt is dirt, isn't it?
Not quite. It's really about gravity and stability. A steep slope just can't hold a lot of weight. Thick soil gravity is always pulling it down over time.
Right, erosion.
And thin soil means less nutrient storage and, crucially, less water retention.
So you can't support a massive, hungry root system of a giant tree on a vertical cliff face?
Exactly. You'll find clinging shrubs or maybe some conifers that are adapted to hold on tight with shallow roots, but you won't find a giant banyan tree hanging off a sheer cliff.
No.
It's just not possible.
So if we take all these variables, temp, moisture, slope, soil, the text then categorizes the results into three big buckets.
Right, the three tiers of vegetation. First up, you have forests.
The VIPs.
The VIPs, I like that.
Yeah.
These are for the places where temperature and rainfall are plentiful. If the equation results in hot and wet, you are going to get a forest.
Okay, makes sense.
Then you have grasslands. This is the middle ground,
Yeah.
the region of moderate rain.
Okay.
It's not a desert, but it's just not enough water to support a dense canopy of giant trees. So nature compromises. It grows grass instead.
And finally, at the bottom.
The shrubs. The survivors. These are for the really dry regions, the hot deserts, or even the cold deserts. Places where moisture is just so scarce that life has to hunker down and be tough.
So it's a sliding scale based on generosity. Nature gives you a lot of rain, you get a forest. Nature gives you some rain, you get a grassland.
Right.
Nature gives you next to nothing, you get a shrub.
That's a perfect way to put it. And today, we're going to walk through that entire scale, starting right at the very top of the food chain.
Yeah.
The forests.
And not just any forests. We're starting with the heavyweights. The tropical evergreen forests.
Also known, of course, as tropical rainforests.
Location-wise, where are we putting our pin on the map for these?
The text places them near the equator and close to the tropics. So you need to be thinking Brazil, the Congo Basin, parts of Indonesia.
And in India.
In India, you're looking at parts of the Northeast and the Western Ghats.
So the conditions, what are they?
Hot and wet. And the key is, it's hot and wet all year round. This is crucial. There is no specific dry season here.
Now, this leads to the name evergreen, and I think there's a common misconception that these trees never lose their leaves, like they have some kind of immortal foliage.
Right. And that's not how biology works, of course. Every leaf dies eventually. It just wears out.
Mm-hmm.
But in a temperate zone, or a deciduous forest, the trees has coordinated strategy. They all say, okay, winter is coming, the water is freezing, let's drop everything to save energy.
It's a mass shedding event, a synchronized drop.
Exactly. But in the tropical evergreen forest, there is no winter. There's no dry season stress. So the trees don't need to coordinate. One tree might shed its leaves in January, and the one right next to it sheds its leaves in March.
So if I'm flying over the Amazon in a plane looking down...
It always looks green. Always. Because while one tree is shedding, its neighbor is in full bloom, hence evergreen.
That makes so much more sense. Now let's talk about the structure. The text uses a very specific word, canopy.
This is one of the most defining features of these forests. The trees are so closely spaced, and they compete so aggressively for sunlight, that their crowns literally link together.
They form a continuous roof.
A green roof, yeah.
And a roof implies that nothing gets through it.
Very, very little. The text explicitly says sunlight does not reach the ground inside the forest, even during the middle of the day.
Wow. That creates a very strange world at the ground level, doesn't it? It must be dark and damp and
difficult.
Yeah.
Extremely difficult. If you are a plant that needs a lot of sun to grow, You simply cannot survive on the floor of rainforest. You will die. It's a very high-stakes environment.
So what does grow there?
Shade-tolerant vegetation, mostly. Or, and this is where the UPSC perks its ears up, you get epiphytes.
Epiphytes. Okay, what are those? Are these the plants that grow on other plants?
Yes, exactly, like orchids or certain types of ferns. If you can't get any sunlight on the ground because the canopy is blocking it all, what do?
You find another way.
You cheat, you climb the tree, you use the tree as a ladder to get up to the sun.
That is a brilliant strategy. It's like living in a penthouse instead of the basement.
It is. It's usually commensalism. They don't really hurt the tree. They just sit on it. But let's pause right here, because we promised PYQs.
We did. Let's link it up.
This specific structure, the canopy, the density, the epiphytes, this was all tested directly in the UPSC preliminary exam back in 2013.
Okay, walk us through it. What was the question?
It was question 55. And the commission asked, very simply, which of the following are unique characteristics of equatorial forests?
Okay, so what were the statements or options they gave?
Option 1 was presence of tall, closely set trees with crowns forming a continuous canopy.
Check. We just read that word for word in the NCERT. That describes the competition for light we just discussed.
Perfect. Option 2, coexistence of a large number of species.
Biodiversity.
And option 3, presence of numerous varieties of epiphytes.
There's our word again, epiphytes.
Now, a lazy student might just know, oh, it rains a lot in Brazil. But a serious aspirant needs to understand the architecture of the forest. The continuous canopy is the cause of the need for epiphytes.
Ah, I see the connection.
And the stable, energy-rich climate is what allows for the coexistence of thousands of different species. They're all linked.
So the answer to the question was?
All of the above. All 3 statements were correct.
It connects the dots. The structure dictates the biology, which dictates the biodiversity.
Exactly. And speaking of biology, we have to talk about the wood itself. The text mentions rosewood, ebony, and mahogany.
These are famous woods, expensive woods.
They are. They're all hardwoods. And economically, they are incredibly valuable for high-end furniture. But there's a catch.
What's the catch?
The catch is that commercial exploitation in these forests is a logistical nightmare.
Why? I mean, the trees are right there. Can't you just go in and cut them down?
Remember option 2 in that PYQ? Coexistence of a large number of species.
Right. High biodiversity.
In a temperate forest, you might have 10 square miles of just pine trees. You can bring in a machine and harvest them very efficiently. But in a tropical rainforest, because of that biodiversity, you might find one mahogany tree. And next to it is a rosewood, and next to that is a rubber tree, and next to that is something else entirely.
So you can't just clear cut and get a standardized product. You have to literally hunt for each specific tree you want.
Exactly. It makes industrial logging very difficult, which ironically has saved some of these forests in the past, though modern machinery is starting to overcome that challenge now.
Before we leave the rainforest, we have to touch on the wildlife. The text drops a pretty terrifying factoid about the anaconda.
Yes. It just casually mentions that the anaconda, one of the world's largest snakes, can kill and eat a large animal like a crocodile.
That sounds like something out of a monster movie. A snake eating a crocodile.
It's the apex of the food chain in that wet, river-dense environment. It just shows you the sheer scale of energy flowing through this ecosystem. Everything is bigger, denser, and more intense.
And the text also gives these forests a famous nickname, the lungs of the earth, specifically the Amazon.
Right, because of the sheer volume of biomass. They're constantly pumping out oxygen and sequestering enormous amounts of carbon dioxide.
Which makes their destruction all the more catastrophic. But we'll get to the human impact a bit later. Let's move slightly away from the equator now. The rain is still there, but maybe it's not happening every single day anymore.
Okay. We are now entering the tropical deciduous forests.
In India, we know these very well.
We do. These are our monsoon forests. You find them in large parts of India, northern Australia, and Central America.
So what is the defining difference between this forest and the evergreen forest we just left?
One word. Seasonality.
The seasons change.
Right. In the evergreen forest, the tap is always on. The water is always flowing. In the deciduous forest, someone turns that tap off for a few months.
The dry season.
And trees are smart. Leaves are very expensive to maintain. They're water-intensive organs, and they lose water constantly through transpiration. So if there's no water coming up from the roots, but the sun is still beating down on the leaves, the tree will dry out and die.
So it creates a defense mechanism, a survival strategy.
It sheds the leaves. It goes dormant. It shuts down the factory to survive the drought.
And that's why in India, come summer, everything just looks brown and stick-like.
Until the monsoon hits, and then it explodes into green again. It's a beautiful cycle of stress and recovery.
What kind of trees are we talking about here? The text mentions a few.
Sal, teak, neem, shifram.
Teak is the big one, isn't it?
It is. And this brings us straight to another PYQ linkage. The UPSC loves teak.
Why? Is it just because it's so common?
It's because it's an economic backbone. The text notes these hardwood trees are extremely useful for making furniture, for transport, for construction materials. If you look around an old Indian house, the door frames, the heavy beds, it's very likely teak or sal.
And it lasts forever.
It's incredibly resistant to termites and to weather.
So let's look at the PYQ 2015 paper, question 78.
The question was very direct. In India, in which one of the following types of forests is teak a dominant tree species?
And the options.
They gave tropical moist, deciduous forest, tropical rainforest, tropical thorn scrub forest, or temperate forest with grasslands.
Well, knowing what we know now, it's definitely not a rainforest. Teak loses its leaves.
Correct, so that's out. And it's obviously not a thorn scrub, so the answer is tropical moist deciduous forest.
This might seem like a simple fact to memorize, but it tells us something really important about how to study. You can't just know the forest types in abstract. You have to map the specific species to its specific forest.
You need that association. Teak equals monsoon equals deciduous. If you break that chain in your mind, you lose the mark. It's as simple as that.
And the wildlife here, it's pretty much the classic Jungle Book cast, isn't it?
It is. Tigers, lions, elephants, langurs, monkeys, animals that are well adapted to that seasonal shift.
Okay, let's pack our bags and move again. We are leaving the tropics. We are heading up in latitude. Things are starting to get cooler.
We are now entering the temperate zone.
And just like in the tropics, it seems we have an evergreen version and a deciduous version. Let's start with temperate evergreen.
These are a little bit trickier to pin down on a map. They are usually found in mid-latitudinal coastal regions.
Coastal. So the ocean is playing a big role here, moderating things.
Exactly. The ocean keeps the air moist, and it prevents extreme temperature drops in the winter. Think Southeast USA, South China, Southeast Brazil.
And what grows here? Is it a different type of tree?
It's a mix. You get both hard and softwood trees growing together. The text mentions oak, pine, and eucalyptus.
Eucalyptus. I always think of Australia, but it's found in these other places too.
It's been widely planted, yeah. It's a very thirsty tree.
So as we move to even higher latitudes, or maybe further inland away from the coast, we hit the temperate deciduous forests.
Right. Northeast USA, New Zealand, Chile, much of Western Europe.
And these regions have a distinct cold winter.
A proper cold winter, yes.
So these trees also shed their leaves, but are they shedding to save water from heat, or are they shedding to survive the cold?
It's actually both. Frozen water in the ground isn't available to the tree's roots.
Of course.
But yes, fundamentally, it's a dormancy period to survive the cold. The trees here are oak, ash, and beech.
And for wildlife, the text mentions pheasants and mommels.
Beautiful birds.
Yeah.
And for mammals, the classics. Deer, foxes, wolves.
Now, I want to stop at a specific biome that the text highlights. It feels distinct. It doesn't quite fit the pattern we've seen so far. I'm talking about Mediterranean vegetation.
Ah, yes. The great anomaly.
Why do you call it an anomaly?
Because it completely flips the script on rainfall patterns.
How so?
In most of the places we've talked about, like India with its monsoons, the rain comes in the summer. It's hot and it's wet.
Right, that's the normal pattern.
But in the Mediterranean region, and that's not just around the sea, it's also California, Southwest Africa, Southwest Australia, it's the exact opposite.
Opposite how?
They have hot, dry summers and mild, rainy winters.
Wait, rainy winters? That's so counterintuitive for a lot of people.
It is. It's due to the shifting of global wind belts, specifically the westerlies, which we can definitely cover in a future deep dive on climatology. But for the vegetation, this climate is a crisis.
Why a crisis?
Because the summer is the main growing season. You've got plenty of sun, long days, but there's no water.
Exactly. Imagine being a tree there. It's July, it's blazing hot, the sun is just hammering you all day, and there is absolutely no rain.
That sounds like a recipe for turning into a piece of driftwood.
It would be if they hadn't adapted so brilliantly. And the text explains this mechanism really clearly. The trees here have thick barks, and this is the cool part, wax-coated leaves.
Wax-coated, what does that do? Think of it like a seal. Or maybe like putting chapstick on a leaf.
Chapstick for a leaf. I like that.
It reduces transpiration. It literally locks the moisture inside the leaf so the relentless sun can't steal it.
And because of this climate, this very specific hot summer, wet winter combo, this region has a very famous nickname, the orchards of the world.
Right. Because it is absolutely perfect for growing citrus
Oranges.
and figs, olives, grapes.
This is where so much of our wine comes from.
A lot of it, yes. And the source notes that because these crops are so valuable, people have removed a lot of the original natural vegetation here to cultivate them.
So if I'm standing in a vineyard in California or an olive grove in Italy, that is not natural vegetation.
Not anymore, no. It's a managed agricultural landscape. And the text adds a kind of somber note here.
Right.
Because the land is so valuable for agriculture and has been settled for so many thousands of years, there really isn't much original wildlife left.
It's a landscape that has been thoroughly domesticated by humans.
Completely.
Okay, so we've done the hot tropics, the moderate temperate zones. Now let's go cold, really cold.
The coniferous forests, the taiga.
First off, that name Taiga, that's a Russian word, isn't it?
It is. It means pure or untouched.
That is poetic.
It fits the landscape. We are talking about the high latitudes here. Think 50 degrees to 70 degrees north. Or at high altitudes in the mountains, like where Salima was on her bus trip.
What does a tree have to look like to survive a minus 40-degree winter?
It looks like a Christmas tree.
Tall, conical, needle-like leaves.
And there is a very clear reason for that shape. If you had a big, flat oak tree canopy, what would happen when it snows?
The snow would pile up on it.
And snow is heavy. It would snap the branches.
So the tree would basically destroy itself.
But with that cone shape, the snow just slides right off. It sheds the weight. And those needle-like leaves, they minimize the surface area to protect against the freezing, drying wind.
It's brilliant aerodynamic engineering by nature.
It is. The trees here are cheer, pine, cedar, and they are what we call softwood evergreen trees.
Softwood. We heard hardwood in the tropics. Why does the text make a point of emphasizing softwood here?
Economics again. It always comes back to how we use it. Hardwood is dense. It's great for furniture. Softwood, that's for pulp, newsprint, and also things like matchboxes and packing boxes.
It's kind of ironic, isn't it? We are literally reading a textbook that was most likely made from the pulp of a tree that grows in the taiga.
We are consuming the biome in order to study the biome.
That's deep.
And the animals here, they aren't worried about heat stroke. They're worried about freezing to death.
So what are their adaptations?
Fur. Thick, insulating fur. Silver fox, mink, polar bear.
So that pretty much wraps up the forests section of the global map. We've gone from the equator to the poles, but there is a whole other category of vegetation where the trees, they just give up.
The grasslands.
This is where the rain starts to get stingy.
Moderate to low. That's the exact phrase the NCERT uses.
And just like the forest, we have tropical and temperate versions. Let's start with the tropical grasslands, the savanna.
This is Africa. This is the Lion King landscape.
It's a very distinct look.
It occurs on either side of the equator, extending out to the tropics. But here's the visual you need to have. The grass isn't like your front lawn. It's tall.
How tall are we talking?
The text says 3 to 4 meters tall.
That is terrifyingly tall. That's taller than an elephant in some cases.
If it is, you could hide a Jeep in it. And living in that grass are the icons of Africa. Elephants, zebras, giraffes, leopards.
Now compare that environment to the temperate grasslands.
These are found in the mid-latitudinal zones, the interior parts of continents. You should be thinking of the prairies in North America or the steppes in Asia.
Is the grass different there?
Very different. Here, the grass is short, but it is incredibly nutritious.
Which makes it perfect for
Grazing. Historically, wild buffaloes, bisons, antelopes, and today, mostly cattle farming.
Now, I feel a PYQ coming on. Grasslands seem simple. It's just grass.
Yeah.
But I bet there's a conceptual trap hidden in here somewhere.
There's a massive one. And the UPSC sprung this trap in 2013.
Okay, tell us.
It was question 22. And it asked about a concept called ecological succession.
Fancy word.
The question was, in the grasslands, trees do not replace the grasses as a part of an ecological succession because of.
Wait, let's pause and unpack that. Normally, if you leave a patch of land alone, small plants grow, then bushes, and then eventually trees take over. It becomes a forest. That's nature's goal, right? To maximize biomass.
Correct. That's the process of succession. But the question is asking, why doesn't that happen here? Why does a grassland stay a grassland? Why don't the trees eventually take over?
Okay, what were the options they gave?
Option A was insects and fungi. Option B was limited sunlight. Option C was water limits and fire. And option D was none of the above.
Well, sunlight is plenty in an open field, and insects seem unlikely to eat an entire forest before it can even start.
So that leaves us with C, water limits and fire.
We know the water is limited, that's why it's a grassland. But fire, that sounds destructive, not like something that maintains an ecosystem.
This is the key insight. Grasslands are prone to seasonal fires. Dry grass burns incredibly fast.
Okay, so there's fire.
Now, think about the anatomy of a plant. Where is the growing point of a blade of grass?
I assume it's at the bottom, because when I mow my lawn, it just grows back.
Exactly. The growing point is right at the soil surface, or even just below it. So when a fire sweeps through a grassland, the top part burns off. But the root and the crucial growing point are safe underground.
So then next time it rains?
It shoots right back up. It just reboots.
Okay.
But a tree sapling, a baby tree, its growing point is at the very top, the terminal bud. When a fire sweeps through, that sapling is completely destroyed. It cannot grow back from the root instantly like grass can.
So the fire acts as a filter, a gatekeeper.
Exactly. It wipes out the tree competition, but it leaves the grass unharmed. You combine that with the limited water, which makes it hard for trees to get started in the first place, and you have a system that actively maintains itself as a grassland, potentially forever.
That is a brilliant piece of ecological logic. It's not just, oh, there's not enough rain. It's fire is the gatekeeper.
And that is the difference between just reading the insert line by line and actually understanding the ecosystem dynamics. That's where the marks are.
So we've covered the places with enough rain for forests and the places with just enough rain for grass. Now, we go to the places where the rain basically just stops.
The deserts.
The text calls this section thorny bushes.
Right, found in the dry, desert-like regions. And geographically, these are almost always found on the western margins of continents.
Why the western margins specifically?
It has to do with global patterns of trade winds and cold ocean currents that literally strip moisture from the air before it hits the land. But that's a whole topic for our climatology deep dive. For now, just remember, west side. Scanty rain, scorching heat.
And the vegetation here is, well, it's unhappy looking.
It's defensive. Everything is designed to survive. Cactus, date palms, acacia.
I remember another PYQ about desert plants. It was about how they defend themselves against the sun and water loss.
Yes, back to the 2013 paper again. It's a big year for vegetation questions. This is question 94. And it asked, which of the following leaf modifications occur in desert areas to inhibit water loss?
This sounds similar to the wax coating we talked about in the Mediterranean.
Same goal stop transpiration, but using different tactics. The options given were 1. Hard and waxy leaves, 2. Tiny leaves, and 3. Thorns instead of leaves.
I mean, I know a cactus has thorns. That's the obvious one.
Right. And here is the cool biology behind that. Thorns are actually modified leaves.
Wait, really? A thorn is a leaf?
Yes. Evolutionarily, they used to be leaves. But a big, flat leaf loses a lot of water. So over millions of years, the plant just reduced the surface area until the leaves become a sharp, hard spine.
So it serves two purposes. Defense against animals trying to eat it, and defense against the sun trying to steal its water.
Exactly. And tiny leaves do the same thing. Surface area and hard, waxy leaves also prevent evaporation. So the correct answer was all of the above.
It's amazing how nature engineers these different solutions to the same problem. If you can't afford to lose water, you change your entire anatomy.
Adaptation is the name of the game. It's the central theme of this whole chapter.
And that brings us to the ultimate test of adaptation, the tundra.
The polar region. We are talking about the extreme north of Canada, Russia, Greenland.
And the conditions there?
Extremely cold. The ground is often permanently frozen, what we call permafrost.
Does anything grow there at all?
Only during the very, very short summer. When the top layer of snow melts just a little, you get this sudden, frantic burst of life. Mosses, lichens, and very small shrubs.
The text calls them short-lived.
They have to be. They have just a few weeks to grow, reproduce, and die before the ice comes back and covers everything again.
And the animals, what's their trick?
Insulation. Thick fur and thick layers of skin or blubber. Seals, walruses, musk oxen, Arctic owls, polar bears, they are basically walking sleeping bags.
So we've climbed the mountain, we've crossed the equator, we've trekked the desert, and now we've frozen in the tundra. But we need to zoom out and look at the bigger picture, section 5 of our outline.
Right, we need to talk about the biosphere and ecosystems. The NCERT gives a simple definition for the biosphere as that narrow zone where land, water, and air all interact to support life.
And within that biosphere, we have all these different ecosystems. And it seems not all ecosystems are created equal.
No, they are not. They vary wildly in their productivity.
Okay, define productivity for us in this context.
In ecology, productivity is the rate at which new biomass is generated. Basically, how much new life is being created per square meter per year.
And this brings us to another great PYQ, question 23 from that 2013 paper. Which one of the following is the correct sequence of ecosystems in the order of decreasing productivity?
Right, so we're looking for the most productive ecosystem down to the least productive.
What were the ecosystems being compared?
The option shuffled 4 different ecosystems: oceans, lakes, grasslands, and mangroves.
Okay. Now, my first instinct might be to think oceans are huge, they cover most of the planet, so they must be the most productive.
And that is a very common trap. The open ocean is actually a biological desert.
A desert? Really?
Yes, it's vast, but it's incredibly nutrient poor in the surface layers where the light is. The light hits the top, but all the nutrients sink down to the dark, cold bottom. So life is actually very, very sparse per cubic meter.
So what's the winner then? What's the most productive?
Mangroves.
Mangroves, the swampy trees on the coast?
Mangroves are biomass factories. They sit at the perfect interface of land and sea. They trap all the rich nutrients running off the land. They have plenty of sunlight. They have plenty of water. The sheer density of life in a mangrove swamp is staggering.
So the correct sequence starts with mangroves.
Correct. The right answer is mangroves, then grasslands, then lakes, and finally, oceans are the least productive per unit area.
That is a really important distinction for our listeners. Don't confuse the size of an ecosystem with its productivity. Just because the ocean is big doesn't mean it's crowded with life everywhere.
Exactly. It's about density, not volume.
Before we wrap up, we absolutely have to touch on the human impact. The source text drops a mind-blowing fact about the Sahara Desert.
This is one of my favorite little nuggets in the whole book. We think of the Sahara as the ultimate desert, just endless sand dunes.
Right, the definition of a desert.
But the text says, you will be surprised to know that present-day Sahara once used to be a lush green plain.
A green Sahara. That's hard to even imagine.
It's true. Archaeologists have found ancient cave paintings right in the middle of the desert. And what do they show? They show rivers, they show crocodiles, elephants, lions, giraffes, ostriches, sheep, cattle, goats.
So people were herding cattle in the middle of what is now the Sahara Desert.
Yes. It was a thriving savanna, just like in East Africa today.
So what on earth happened?
Climate change. Natural climate change. Over thousands of years, the text says the change in climate has changed it to a very hot and dry region.
That is genuinely chilling. We think of climate change as this modern industrial problem, and it is, but the climate has shifted naturally in the past with absolutely devastating consequences for the vegetation.
It shows how fragile these systems are. It can turn a paradise into a desert. It just underscores everything we've talked about today. Vegetation is a slave to climate. If the climate shifts, the entire map of the world changes. The forests move, the deserts expand.
That is a very powerful thought to hold on to as we go through this.
It really is.
Okay, let's try to unpack this whole deep dive. We've covered a lot of ground. What are the key takeaways for the learner, the UPSC aspirant listening to this?
Okay, first, the core equation. Height plus climate equals vegetation. Remember that temperature and moisture are the bosses. If you change them, you change the life that can grow there. The 3 zones. Forests are for the wet places. Grasslands are for the moderate places. Shrubs are for the dry places. It's a simple, powerful framework.
Third.
The details matter. The PYQs prove this over and over. Knowing that teak is deciduous. Knowing that fire is what keeps grasslands as grasslands. Knowing that epiphytes are a clue for rainforests.
Then fourth.
Adaptation. Nature always finds a way. Wax on leaves to stop water loss, thorns to fight the sun, cone shapes to shed the snow. Every plant you see is a clever solution to a very specific environmental problem.
And finally, let's bring it all home. This so what? Why should our listener care about any of this?
Because this isn't just trivia for a geography quiz. Understanding these biomes helps you answer complex, interconnected questions. It's about agriculture.
Yeah.
Why do we grow citrus in the Mediterranean? It explains the economy. Why do we get paper from the Taiga? And most importantly, it frames the entire global conversation on climate change.
Absolutely. Which brings me to my final provocative thought for you to mull over. The source mentioned the Sahara was once lush and green. If climate dictates vegetation, and we know for a fact our climate is changing rapidly right now, what will the map of natural vegetation look like in 100 years? Will the Amazon turn into a savanna? Will the tundra melt and turn into a forest? We are living through a geological shift in real time.
That is a frightening and fascinating question to end on.
It is. And on that note, we are going to sign off. A quick final reminder. If you want the premium notes, the extra PYQs, and the model mains answers, join the Simplified UPSC by PPP, private Telegram library. Just DM us on the Pubble channel to get in.
And please don't forget to like, share, and comment on this deep dive. Tell us what surprised you the most. Was it the anaconda eating the crocodile? Or the idea of a green Sahara?
And a massive final thank you to our patrons for making all of this possible. You guys rock.
Keep learning.
Keep exploring. See you in the next deep dive.